I am Jonathan, and here I have the Times Square watch. It is basically a do-it-yourself watch that whenever you click the button, the time rolls by, and it also has different modes for a binary watch and also a moon phase and a battery gauge. So now let's take a look at what's inside. If you look here, we have the matrix on one side, and then on the other side we have a Atmega 328P, a I2C clock unit. I forgot the exact model number. We have an oscillator, we have a bunch of resistors and 2 push buttons and a battery and a small lithium-ion coin battery. So let's take a look at every specific part and try to give a brief explanation of each. So let's start with the brains of this. We have the Atmega 328P, which is very similar to the Atmega 328, which is used in the Arduinos, but this one's a low power unit, so that means it could run on lesser power, because this watch, it's key for it to run on the least power possible, because if it, longevity wise, if we want it to last on one little battery, we need it to last, we have to get the most that we can out of it. So we have this Atmega, the low power version, and so it's getting input from this little timer and from these buttons, and what it's doing is it's outputting on this LED matrix the time, or if you have selected different mode, it was upside down, if you select a different mode, it has the other stuff. So that's a simple explanation of what the Atmega does. And then we have here, we have the timer unit, which basically it's much more precise in keeping time than the Atmega, but it's small, it's good, but it doesn't run alone. It uses this crystal oscillator right over here, this little silver thing, which basically has a pulse, and it's very, very precise and accurate, and it's extremely small. So the little timer unit reads off of that oscillator, and it keeps track of the time, and then it sends the time to the Atmega. And then we have a whole lot of these resistors. We have about 8, I think, 40 ohm, I think, resistors, which are used for the matrix. When the Atmega outputs to the matrix, we want to limit the current so that we don't burn the matrix. So that's pretty basic. And then we have another 10K resistor, which I think is somewhere around here, or actually here, I think. Yeah, here, with this 0.1 microfarad capacitor that are used only for the FTDI, which is down here, which is basically a sort of like a little device that you connect to this, and it allows you to reprogram this small watch on the computer. And then we have these two buttons. They're basically like a little door. When you click it, it closes the circuit, and it allows for the power to go through, and then the microcontroller senses that, and it respectively does something in the code. Like, for example, if you hold it for 2 seconds, it changes the mode, and now we're at the battery mode. And then, last but not least, is the battery, which is a lithium-ion battery. It's 3 volts, so it's very small. It has a nice amount of volts, and it has about 200 milliamps. And I believe that's about it. Oh yeah, and also the matrix is basically a lot of LEDs put into a little compact piece. It's 8 by 8, so therefore it's like 64 LEDs, and this is similar to the technology that they use in LED TVs and other stuff, except it's much bigger and much more LEDs. So this is the battery mode, right? So it's full battery. It's 10:35 right now. Then if you hold it for 2 more seconds, let's see this. It has the date, and then you hold it for 2 more seconds. This is binary. Then you hold it for 2 more seconds. It should go to moon phase, so it's a full moon. Yeah, and that's basically it.